Check, check, check. How's everything sounding? Check, check, check. All right. Desktop audio. Why is that? Check, doubled check. Up. How's everything sounding? Check, check. Probably because it's coming out of there, huh? Desktop check, audio. Check. Why is that? Check, doubled check. Up. Yep. All right. Ready. Hokie dokie. It is 9 a.m. We're going to get started. We have a lot of problems to go over today. So just want to make sure this is showing up on there. Hopefully it should be in just a moment. Make sure I see it though. Yeah, we're good. Unfortunately, my webcam is having difficulties sharing on the Zoom thing while I'm on the screen capture share thing. But anyway, so hopefully everything else is still solid. Let me just do a sound check so I can make sure I hear myself here. Anyway, so yep, we're good. All right, let's get started. Shout out to Jeffrey for sending me this problem to work out. Let's get started. If you send me any problems to my email, make sure to just say something in the chat so I know to go look at it. Otherwise, I'm just going to keep working through problems. All right, let's get started. So this one was in, I think, the very first quiz, one of the first quizzes at least. And this problem, basically what you want to do is simplify things using properties of exponents as much as you can. So I recommend with this first piece here, anytime you see 1 over a divided by b, this is equivalent to b divided by a. Basically, 1 divided by a fraction is equal to the flip of that fraction. So if we apply that to the 1 over x, we get x over 1, and it remains cubed. And so if we just have x over 1 cubed, that's really just x cubed. So what we just found out is that this whole thing here is equal to x cubed. So then we work out this piece here. Anytime we have a 7th root or any number root, that goes in the denominator of the exponent that is a fraction. So we have x to the 5 over 7. So now we have these two terms that are much easier to deal with. And when we multiply two x terms with different exponents, we add their exponents. So we just want to add 3 and 5/7. You could do this on a calculator. You could do this by hand. I'll just work it out by hand real quick. 3 plus 5 over 7. In other words, 3 over 1 plus 5 over 7. We need to get a common denominator. So we multiply the top and bottom here by 7. 7 times 3 is 21. 7 times 1 is 20, or is just 7. So then we add the numerators. 21 plus 5 is 26. Leave it over 7. And that tells us the exponent of the x term is 26 over 7. Excuse me. And that is it. Alrighty, I'm going to move on to the next one. Also, I just want to say, BP, thank you for the good energy. Shout out to everyone. That's very kind of you. Shout out to everyone is right, or good luck to everybody is right. Alright, so shout out to Ujwal for recommending these problems. Let's jump into it. These are very easy as long as you break them down, break down what you're looking for. So we want to know whether this function will have a max or a min. Max or min is dependent on whether the x squared term is positive or negative. So a positive x squared term leads us to a parabola that's opening up or concave up. Anytime we have a negative x squared term, it's a parabola that's opening downward, which means the positive x squared would lead to a minimum, while the negative x squared leads to a maximum. So that helps us for this one, since we have negative 3x squared, we're dealing with an opening down parabola, which leads to a max. So it would not be any of these minimum options. And then to find the x value, where the vertex occurs, or where the min or max occurs, we do this. So x equals negative b over 2a. And so the a, b, and c come from these values here. So negative 3, positive 6, and negative 7, respectively. Really, we don't need the c value, but negative b over 2a in this case would be negative 6 over 2 times negative 3. So we'd get negative 6 over negative 6, which would give us a positive 1 for our x value. Again, this is the x value where the maximum would occur, where the vertex would be. And so this ordered pair has the positive 1 for the x value, while this one has a negative 1. So we can eliminate option D, leaving us with B. So same idea here. positive x squared leads to a minimum opening up curve, right? So we eliminate the maximums. And then in this case, it's kind of special because even when we find negative b, negative 24 over 2a, we get a positive 24 over 8, which is a positive 3. But you see both b and c have positive 3. In this case, you would plug the 3 in to the function wherever you see x and just find what that function value is, or find what that y value is. And that's it. So I won't go into depth on that. You should get 2.5 when you plug it in, which is equivalent to 5 over 2. All right, let's keep it rolling. The rest of these are just problems I've picked out that I think are pretty important, that I could likely see on the exam. So we're just going to jump into these. This is a version from quiz 3, and this is a version from quiz 13. And these problems have pretty much the same exact process. So I'm going to open up Excel. Oh, I think I actually have it open already. All right, so we are going to try to share this while we're sharing this. If I can stretch these properly. All right, hopefully this is solid enough. I'm going to cover the chat for a little bit. Sorry. All right, so what we're going to do is, what they're asking is, price and revenue. They're giving us price and revenue values. They say use a scatter plot and create an appropriate trend line for the data. Okay, so we're going to plug in these values first. In the first column, we want the price value. So 5, 6, 8, 9, 11, and 14. In the second column, we want the weekly revenue. So 177.9, 204.5, 249.3, and so on. All right, so once we have these typed in, I really hope this goes away. This is quite annoying. Once we have these typed in, we want to highlight these and insert a scatter plot, like they say. And here we get this scatter plot, and every single time, they always say like fit an appropriate trend line, but every single time what you'll want to do when you plot the scatter is go to add chart element. If it doesn't pop up in the top left, I think you can click on the chart like this, and then it should pop up here. We go down to trend line. We skip over all these, go to more options, and we always click polynomial. We are not doing a line of best fit. We're doing a curve, a polynomial, a parabola of best fit. And then you'll click on display equation on the chart. That'll give you this equation here, and this is what we will plug in the x value they give us to. So they tell us, they ask us to estimate the revenue when the price is 12. So to estimate the revenue, the y values that we plugged in are the revenues. And so if we just plug in 12 for x, we should have our answer. And we can do this in Excel. So negative 1.4 times 12 squared. Got to make sure I have the asterisk. Yep, they corrected it for me. Let's keep going with it. And then plus 42 times 12. And then plus 2.9. And when we do that, we get this 305.3, and that is option E. That is our answer down here. So that's pretty much it. Again, with this one from quiz 13, the only difference really is you would plot the number of accidents in the first column. I wonder if we can do it just real quick. 1, 3, 6, 7, and that's it. We can eliminate these two. And then you want just the prices, or the, it's basically like the insurance costs for the age of a 22-year-old, because they only ask for the 22-year-old information. So 467.47, 549.47. Oh wait, I just made that up. 549.31. Sorry, I'm all over the place here. 665.32 and 702.19. And now hopefully it's changed it for us automatically, because we've kept this chart based on this information here. So they give us this information, and it's still the same process, mind you. So it's still all the same stuff with a polynomial of best fit. And so now they want us to know, what would it be if we had 0 accidents, meaning we are plugging in 0 for x in this function. When we do that, this x term goes to 0, which makes this whole first term go to 0. This x goes to 0, this goes to 0. So all we're left with is 425.2, and that is our answer here. And that's the idea. All right, let's keep it rolling. Let's get rid of Excel. Let's bring this baby back into view like so. Hopefully everything's visible here. Let's just check on here. Oh, it's beautiful. All right, let's keep it rolling. Got a lot of problems I would love to cover. All right, great problem from one of the first quizzes. It's about demand and supply and demand. They're asking about the price they would have to sell each donut in order to neither have a surplus nor shortage. And so the idea is we want to find a function, a linear equation, y equals mx plus b, for both supply and demand. Once we do that, we will set these functions equal to one another and solve for x. So real briefly, this is kind of what we're using here. So the ordered pairs we will set up for supply. Looking down here, they say they will only supply 50 donuts free, and so we want the price comma donuts. So free means 0, and donuts in this case is 50, so 50 free donuts. And then if they sell them for 50 cents, they will supply 150. So 50 cents is the price, and then 150 is the quantity of donuts. So we have 2 ordered pairs here. Let's go and find the 2 ordered pairs for demand. So the demand is 225 when the donuts are free. So 0, 225. And then 25 cents when they sell 150. So 25 and 150. So with 2 ordered pairs, you can always construct the equation of a line. First thing we can find is the slope. So if we find the slope, y2 minus y1 over x2 minus x1 here, we get 150 minus 50 divided by 50 minus 0. So that is 100 over 50, which gives us 2. So 2 is our slope for the supply function. Now for y equals mx plus b, we need the m and we need the b. So the m is 2, and now the b value is found from this ordered pair. Whenever x is 0, the corresponding y value naturally is your y-intercept. And so they give you the y-intercept pretty directly. So b is 50, which means if we plug these in to mx plus b, we have y equals 2x plus 50. All right, so now we do the same thing for the demand information. So let's give it a shot real quick. We can do 150 minus 225 divided by 25 minus 0. So this is finding the slope between these 2 points. That is negative 75 over 25. Imagine quarters. If we have 75 cents divided by 25, we have 3 quarters, and that is negative just because one of them was negative. So m equals 3 here. And the same thing applies. Wherever x is 0, the corresponding y value must be the y-intercept, must be our b value. All right, so we have m equals negative 3 and b equals 225. So we set up negative 3x plus 225. So we have the supply function, the demand function, and we want to know where there's neither a surplus nor shortage. So we set, that's a lot. So we set supply equal to demand. So we're setting 2x plus 50 equal to negative 3x plus 225. We can solve for x now. So we add 3x to get 5x, subtract 50 to get 175. We divide by 5, and we find that x equals 35. Because we didn't use decimals, we know that 35 means 35 cents per donut. All right, little scrambled and jumbled in here. I don't know why I put these so close together, but I hope that makes sense. Let's keep going. This I could totally see as like a solid fundamental problem on the final. Let's jump into it. They ask us to find the weekly profit if they sell this many bobbleheads. Profit is revenue minus cost. Revenue is price times quantity. Cost is variable cost times quantity plus fixed cost. So the revenue will be the price that they're selling the bobbleheads for. Where do they say that? They say bobbleheads sell for $17. So 17 times the quantity that they are selling, so 13. 17 times 13 will give us the revenue. I'll just do that in my phone real quick. 17 times 13 gives us 221. Now cost will be the variable cost of 7 still times the quantity plus the fixed cost of 55. In my phone we get 146. We have revenue and we have costs. So we take revenue and subtract the cost. And real quick in my phone, 221 minus 146 gives us 75 for revenue minus cost. That is our profit. All right, let's keep it rolling. Awesome problem here, a serious problem. Let's jump right into it. They ask, what is the percent change in revenue for the bike shop? Percent change in anything is new minus old divided by old. I'll represent it in terms of R1 and R2. R1 being the old revenue, R2 is the new revenue. So this is our goal. This is what we're trying to calculate. So then the question is, how do we calculate revenue? We know that revenue is price times quantity. So what we want is the first price, the first quantity, second price, second quantity. Let's see what we can find in the problem right away. A bike is sold for $191. That's the first price. They sell 200 when the price is $191. That's our quantity 1. So we can find revenue 1 right away. I'll go ahead and find that. 191 times 200. We get 38,200. And then the second price they tell us is the 227. So we're 3/4 done with what we need to find. The only issue really is we don't know what the second quantity is. They don't tell us. So we have to use the information given to identify what that is or calculate what that is. How do we do that? We are given the elasticity is negative 0.2 and we are given the percent change in price is 18.85%. We plug those two values into this equation. And so this is our big elasticity equation. I recommend knowing this going into the final. Plugging in negative 0.2 for our elasticity, we want to find percent change in quantity. And then the percent change in price in the denominator here is given to us as 18.85%. So I will represent that as a decimal. So 0.1885. Now our goal is to solve for percent change in quantity. The way we do that is just by multiplying the 0.1885 to the other side, to negative 0.2. In my phone real quick, negative 0.2 times 0.1885 gives us negative 0.0377. That is our percent change in quantity. Keep in mind, we know that to find percent change in something, we do Q2 minus Q1 over Q1. That's the new minus old divided by old. And we know that percent change in quantity here is negative 0.0377. So using this, our goal is to solve for Q2, and we have Q1. So we can plug in 200 wherever we see Q1 here. And now we have an equation for which we can solve for Q2 by multiplying to the right side this 200. When we multiply that decimal on the right by 200, we get negative 7.54. Last step is just adding the 200 to the right side. This gives us our second quantity of 192.46. So that is what we plug in up here for our second quantity. Now we have what we need to calculate that second revenue, right? So we'll just multiply 192.46 times 227. That gives us 43,688.42. We have R1, we have R2. We plug these babies in here. So R2 minus R1, I'm just doing this in my phone real quick, gives us 5,488.42. That's R2 minus R1. We divide that by R1, 38,200. That gives us 0.1437. As a decimal, it's 0.1437. As a percentage, that is 14%. And that's the whole process. Let's keep it rolling. If anyone has any questions on anything, try to hit the chat before I keep moving on. If you have any questions you want to see worked out, send them to my email and let me know that you've sent them. Otherwise, I'm going to keep rolling here. In this problem, they give us a function, a regular function f of x, and the goal is to identify f prime of x. Here's all we need to know right here. We want to analyze where f has a positive slope, because that will tell us where f prime is above the x-axis, or positive. Wherever the original function has a negative slope, f prime should be negative, or below the x-axis. So usually I just like to start off by looking at the original function here. So I'm going to zoom in. I know people hate when I zoom in. Let's keep it rolling though. We look at the start here. At the very start, the leftmost side of the graph, this starts with a slightly negative slope. It's decreasing, so it's just a barely negative slope on the original graph of f, which means when f has a negative slope, f prime is negative or below the x-axis, which means if this starts with a negative slope right on the left side here, that means on f prime, on the far left, it should just barely start below the x-axis because this starts with a negative slope at the very start. So there's only one color that starts below the x-axis at its leftmost point, and that is blue. And that's it. You can simply look at the very start, and that'll usually be enough. Something else to add is that this has a negative slope only up until about negative 1.4. And that's why this blue curve on f prime crosses the x-axis at about negative 1.4. Those should always match up. All right, let's do one more example real quick. Starting off by looking at the leftmost point. This graph, f of x, starts off with a positive slope. It's increasing. It has a positive slope up until about, I'll probably curve that a little bit. It's about negative 1.25 or 1.3 or something. So we're looking for the graph over here that starts above the x-axis. And really the only one there is orange. So orange starts above the x-axis, and to solidify it, it does cross at about negative 1.25 on the x-axis. And so that solidifies that orange is our answer. All right, let's keep it rolling. In this problem, they ask us to list A, B, and C in order of decreasing. Instantaneous rate of change. Anytime you see the phrase instantaneous rate of change, all it means is derivative, or really even easier, the slope of the function. they're asking us to order these in decreasing slope order, so from most positive to most negative slope. So I kind of arrange what that essentially looks like here, most positive to most negative. So looking at A, B, and C, it helps to first identify which ones are on a positive slope, which ones are on a negative slope. C is on a very positive slope, very steep slope. The steeper it is, the more positive it is, or the greater value. So like the steeper it is in the negative direction, the more negative it is. B is also on a positive slope, but maybe a little less steep. A is just barely on the end of a negative slope, so just barely negative. So from most positive to most negative, C and B are positive, so they should come first. C is the more positive, or the more steep, so it definitely comes first. B comes next, and then because A is our negative slope, it'll be at the end. CBA. Let's keep it rolling. In this problem, I thought this was a good, simple one to include because it includes the super helpful idea that any time in this course, when you see marginal cost, marginal profit, marginal revenue, typically in this course, it means the derivative of whatever they're talking about. In this case, marginal cost represents the derivative of cost. In other words, the rate of change of cost at Q equals 68. To estimate the slope or the derivative at one point, we always want to pick values to the left and right of it and then find the slope between those 2 points. The slope between here and here will be a great estimate for the slope right in the middle. Slope formula: y2 minus y1 over x2 minus x1. Cost values are like the y values, q values are like the x values. So 1370 minus 1240 divided by 72 minus 64. Calculating this real quick, what do we get? I think that's 130 divided by 8. In my phone, 130 divided by 8 gives us 16.25. That is approximately 16.3 per case. Let's keep it rolling. All right. In this problem, they give us the population changes over certain intervals. And at the very end, they ask us, what is the average rate of change over the entire 49-year period? So, what they're asking us to find is the slope from start to finish of the entire 49-year period. So that's what we'll do. We first need to find two ordered pairs, one representing the start of the period and one representing the finish or the end. I'll call it the end of the period. And so we know that at the start, the time is 0, and at the end is 49, because they ask about the entire 49-year period. Also, there's 22 years that go by, and then an extra 27. The sum of those is 49. So at the very, very start, the question is, what's the population? Because that will correspond to our y value. At the very start, the population is 4075 or 4075. They tell us over the first 22 years it increases to this 10,000 value. Then over the next 27 years it only increased by an extra 181, which means to find the population at the very end, we want to take that 10,000 value and add on the 181. And that's it. So we have our start and finish ordered pairs for the time and population of the entire period. So we just plug these in to slope formula. Second y value here minus the first y value, all divided by the change in x values. So calculating this on my phone real quick, 10,745 plus 181 minus 4075 gives us 6851. we divide that by 49 minus 0, or just 49. That gives us 139.82. So that is approximately 139.8. All right, let's keep it rolling. Just want to do a sound check. I have like a fear that it's just not. That is approximately 139. All right, we're rocking. Let's keep it rolling. In this problem, the long way of going about this problem, or an important equation to include here, is this extra elasticity formula that says P over Q, or elasticity is equal to P over Q times 1 over P prime, the derivative of P. We could use that in this case by doing basically like this is P, this is Q, so we'd have 280e to the negative Q over 26 divided by 31.2, and then we'd need 1 over P prime, which would be the derivative of P. And so what you could do in this problem, they wanted you to like estimate P prime, but using what we know about derivatives, we could actually find P prime if we wanted to. P prime would be 280. The derivative of e to the anything is e to that same anything. And then we would multiply this, though, by the derivative of negative q over 26. Negative q goes to negative 1, and then the 26 stays on the bottom. So again, this uses a slight chain rule. E to the something was like the derivative of the e term, the outside, and negative 1 over 26 is the derivative of the inside, the exponent. And so we could plug all of this in there. And the important thing is you would make sure to plug in the q value, 31.2, in place of this q and this q. And then you would just calculate this whole thing. And in the end, what actually happens is it ends up simplifying to just negative 26 over 31.2. So what I'm hinting at here is when you get this problem with this format, you can use this shortcut. So negative 26 comes from this exponent here. So just negative 26 divided by the q value, 31.2. Let's give it a shot in the calculator. Negative 26 divided by 31.2 gives us negative 0.83 repeating. And that's our answer. And just as a reminder, it is inelastic because if you took the absolute value of it, you would get positive 0.83, and the absolute value of it is less than 1. When the absolute value of n, or the elasticity, is less than 1, this means you have an inelastic demand. If you had something like negative 1.2 or 2.3 or something, these values are elastic because their absolute values are greater than 1. And if you ever have elasticity equal to 1, that is unit elastic. So positive or negative 1, that's unit elastic. All right, let's keep it rolling. Cruising through these problems. Hopefully we can get all these ones done that I would like to. All right, great problem here. I could totally see this on the final. Let's talk through what they want us to find. Using this model, estimate how much faster the population will be growing in 1 year compared to another. So what I recommend using here is the rate of change of the population function. P prime is the rate of change of the population function. So what that means is if we plug in any t value, any year, into this function, what it'll tell us is the growth rate, how fast the population is growing in that year. And if we want to find how much faster the population is growing in 1 year than another, then that means we want to find P prime for both the years 2024 and separately 2003, and then find the difference of them. So we first want to know what is the t value that represents the year 2024. Then we want to know what's the t-value that represents 2003. They tell us that t is the number of years since 1993. So we find the difference of 2024 to 93. So that's 7 years to get to 2000, and then 24 more years to get to 2024. So 7 plus 24 is 31. And then 1993 to 2003 is just an even 10 years. All right. So again, we want to find P prime at 31. And we want to find P prime at 10. And then we want to subtract the two. Something I haven't yet mentioned is this whole derivative of P. Something nice is that P prime will always be this because the P function they give you is always this. But also, this uses the exponential rule for derivatives. That is, a to the t has a derivative of a to the t times ln of a, where a is a constant. All right, let's keep rolling. So we are finding this. I'm just going to plug all of this directly in to Desmos. Whoops. All right, there we go. So we are plugging in 31 and 10 into P prime and then subtracting them. So 1.15 times 1.014 raised to the 31. All of this is times the natural log of 1.014. And we get 0.0246, and that would be, the first value here, P prime at 31, but let's go ahead and plug in the entire minus P prime at 10. So minus the same function with 10 plugged in. So 1.15 times 1.014 raised to the 10, and this is all times the natural log of 1.014. And as a result, we get this 0.0062. 0.00623 if we kept that last decimal there. Keep in mind, the function p is in billions. So what we just found is that the population in the year 2024 is growing 0.00623 billions more or faster, billions per year faster than 2003. So basically we just want to multiply this by 1,000 to get it back in millions per year. So this will give us that 623 mil per year. And that's it. All right, let's keep rolling. Great problem. I could totally see this on the final just because it's regarding derivatives as well as profit. Very fundamental things in business calculus. So in this problem, they ask for the marginal profit. Again, anytime you see the word marginal in this course, I usually want you to think derivative of whatever they're talking about. So marginal profit is the derivative of profit, which means if we use these functions, the cost and revenue, to find first the profit, then we can find profit's derivative, then we can plug in 24. Profit is revenue minus cost. So profit in this case is revenue, which is 4Q plus 250 Q, and then minus in parentheses 3Q squared plus 40Q. So if you wanted to, you could take the derivative of each of these terms first and then subtract them, or you could subtract them first, then find the derivative. So I'm going to subtract them first. 4Q squared minus 3Q squared is 1Q squared, or just Q squared. 250Q minus 40Q is 210Q. This is our profit. So to find the marginal profit, we want to take its derivative. P prime is 2Q plus 210. 2 comes out in front, and 210q, a constant times q, just goes to that constant. So we get 2q plus 210. And now we just plug in 24 because they ask for the marginal at q equals 24. All right, trying this out by hand, we get 48 plus 210, so we get 258. And that's it. Let's keep it rolling. Difference quotient. Difference quotient might come up, so it might be important to know this formula, but if you're feeling overwhelmed by everything else, odds are maybe it won't pop up. So but I still want to go through it because I think it's kind of important in calculus in general. So they ask us to find the difference quotient for this function and for this a value. So eventually we want to find f of a plus h minus f of a over h. This is the difference quotient. Generally, I start off with finding f of a. If they tell us a equals 2, then finding f of a is just finding f of 2. To find f of 2 when you're given a function f means just to plug in the value 2 wherever you see x. And so if we calculate this real quick, we'll get negative 9 times 4, so negative 36, plus 9 times 2, which is 18, minus 6. I'll just do this in a phone so I don't regret it. 36 negative plus 18 minus 6 is negative 24. So this negative 24 is f of a. So negative 24 will be plugged in here eventually. Now it might help to find f of a plus h. Here's the trickier part about this problem. Again, we are told that a is equal to 2. So really we are finding f of 2 plus h. 2 plus h in these parentheses means we want to plug in 2 plus h wherever we see x in the function. So we are replacing all the x's in the original function with 2 plus h. And the tricky part, the real tricky part about this is actually expanding the 2 plus h squared. You want to make sure when you expand this here that you are treating it as 2 plus h multiplied by 2 plus h. And then we will multiply that by negative 9. So 2 plus h squared is equal to 4 plus 2h plus 2h, or just 4h. And then h times h is h squared. I'm going to go ahead and multiply all these by negative 9. Negative 36 minus 36h minus 9h squared. Mind you, we still have all these other terms. 9 times 2 is 18. 9 times h is 9h. We have minus 6. So sorry about interfering with this one here. I'm going to move this down if I can. Give us some more space. All right, so simplifying this, we have a 36, we have an 18, we have a negative 6. I believe we saw these same values back here, which means we should get negative 24. We have a negative 36h plus a 9h. That should give us negative 27h. And then we have a negative 9h squared. So gathering all the like terms and simplifying and all that gives us this, which again was all equal to f of a plus h. So this, the result we just got, will be plugged into f of a plus h. So we have the two main things we need, f of a plus h and f of a. So now we plug these in to the difference quotient. We have negative 24 minus 27h minus 9h squared. We are subtracting f of a, so subtracting negative 24, and we divide this all by h. Again, that was just this formula. The negative 24 is the f of a values should always cancel out, because minus a negative 24 is like plus 24, right? So that goes away, that goes away. we have two h terms being divided by h, which allows us to cancel an h from both terms up top. So 1 goes away here, 1 goes away here, that goes away. We have negative 27 minus 9h, or negative 9h minus 27. And that's it. All right, let's keep it going. This one I think is important because it uses one of our important interest compounding formulas. So this is the big one we will use in life, really. So it's interest that is compounded continuously. In any problem where they say compounded continuously, or continuous exponential growth, or continuous exponential decay, continuous is the key word that tells us to use this formula, this equation. And so A always represents the amount of your investment at some time. P is always your principal, or your initial amount that was invested. E is just E. R is the rate of growth, and T is time in years. So for this problem, let's use what we're given to set up two equations and talk about what to do with those. I'm going to start with the greater valued numbers. So they're giving us essentially ordered pairs, almost like x and y for both of these. So x and y for the second one. Or in other words, t and a values are like our x and y values. So they're telling us the amount, the a value at year 16 is 2,485.95. And so we have p to the r times 16. That's all we can plug in because that's all we know about this equation. But then we can do the same setup with the other pair of information. The reason I did the larger values on top and the smaller values on the bottom is because what we want to do is divide these two equations, dividing each of these by one another. So it's basically like this division is equal to this division. So now we can divide these numbers on the left, the thousands values. So I'm going to go ahead and do that. 2485.95 divided by 1878.84. And that gives us 1.323. Now, simplifying this right side is the important piece. P divided by P can cancel. Anytime we have an E term divided by an E term, but with different exponents, we subtract their exponents. So 16R minus 8R leaves us with 8R. Our goal now is to solve for R, and then we'll talk about what to do next. We solve for R by eliminating E by taking the natural log of both sides. ln and E cancel. We are left with just 8R on this side equals, and the ln of that value gives us 0.28. Now we divide by 8 to get R by itself, and we find that R is equal to 0.035. Now we found R, but they're not looking for R. What are they asking for? How much did your parents put into the certificate at your birth? In other words, what was the initial investment? In other words, P. They're asking for the principal value. So now that we have R, we should be able to easily find the principal by plugging R back into one of the initial two equations that we set up. So I will just use the smaller valued equation. You can use either one. So we're setting up 1878.84 equals P, which is what we're looking for, E to the R times 8. So R is what we just found, so 0.035. And then that's being multiplied by 8. So if we solve this for P, we'll be good. Let's calculate this E value first. So E raised to the 0.035 times 8. I'll go ahead and do this one in Desmos. E raised to the 0.035 times 8. And that'll give us 1.323. So we have this, same deal on the left, equals P times 1.323. So really that whole E term is just a constant next to that P term. If you have a constant times P and you're trying to get P by itself, we just divide by that value to eliminate it and get P by itself. So 1878.84 divided by 1.323 should give us our answer. 1878.84. 1878.84 divided by 1.323 gives us 1,420. And that is our P value. That's the principal amount that they put into the account at your birth. All right, I need to take a bathroom break, so I'm going to pull up the lovely review sheet that I put in last semester. It's very helpful to use, so I'm just going to leave this up in case anyone wants to reference some knowledge there. I'll be right back. Thank you for waiting. Hokie dokie. Thanks for waiting. Let's get back to it. Just want to make sure y'all can hear me. Let me make sure I have the chat pulled up. All right, we're good. All right, let's keep it rolling. Again, if you have any questions you want to see worked out, feel free to send them to my email. New music from Jack Harlow. Oh boy. All right, let's keep it rolling here. Cool little problem here. I really just kind of want to go over the shortcut for it, just in case it pops up. You have a quick way to go about it. So in any of these problems where they're talking about population of fish, what you'll do is identify the two constants in the denominator. One of them is not attached to an E term. That's the 1. One of them is attached to the E term. That is 0.56. And then there's an operation between the two, so either addition or subtraction. Whatever there is, you want to do that with those two numbers. And then you will always divide by the value that's not attached to the E term. That's the 1. This will give us 0.44 divided by 1, or 44%. Let's keep it going. Another example of that. So two numbers on the bottom. Whatever operation is between them, you perform that operation. So 3.64 plus 4, then we always divide by the value that's not attached to E. So 4. Up top, we get 7.64. And when we divide this by 4, in my phone, 7.64 divided by 4 is 1.91, which as a percentage is 191%. So nice little trick there. Let's keep it rolling. Another interest compounded type of problem. but this one uses the other equation. How do we know that this one uses this equation here? It's all dependent upon if they tell you that interest is compounded a certain number of times per year. So you might hear it say, might be called like compounded periodically rather than continuously. Really just look for, if it tells you a certain number of times per year that is compounded, you'll be using this one, because the only different variable with this one compared to the A equals PERT equation is the M value, and M represents the number of times per year it's compounded. Therefore, in this case, M is equal to 2 for 2 times per year. So the beautiful thing about this problem specifically is that it looks super crazy, but as long as you know you're using this equation, they actually give you everything to plug in on the right side of the equation. P is the initial investment. They've already paid this much to build some whatever. And then it's 1 plus R, which is the rate of 6%. Anytime you have a rate of 6, make sure to use the decimal version of it, 0.06, in any equation or any formula you were using. We do R divided by M, which is 2, and then we multiply by M times T. What is T? T is time in years, so 10 years. And I'll work it out real quick on Desmos, but this is all we need to do is calculate this. Let's open up Desmos. So 160,000 all multiplied by 1 plus 0.06 divided by 2 raised to the 2 times 10, which is 20. And we get 288,977.79. 288,977 is close enough. And that's the whole process. Let's keep it rolling. All right. Classic standard derivative problem that uses the chain rule. So I'll talk through this as efficiently as possible. When finding the derivative using the chain rule, it helps to recognize the layers that we are finding derivatives of. The outsidemost layer is the e. Anytime you have e to the something, its derivative is e to that same exact something. And that's it for the outside layer. Our next layer is the something raised to the 4th power. If you have something raised to the 4th, it's very similar to x to the 4th, where you would get 4 times that something to the 3rd power. So that something being raised to the 4th in this case is the ln of z. So ln of z remains unchanged as we take the derivative of its outside layer. And then the innermost layer is the ln of z itself. So then we find 1 over z. So then what we're looking for is the answer that has this, this, and this all multiplied together. So this z on the bottom should tell us it's either A or C. And then we are also looking for a 4 and an ln of z cubed. We have a 4 and an ln of z cubed. And so eliminating answers that don't have the necessary terms in our derivative helps us identify our correct answer. And now we have our e term, the 4, the ln of z cubed, and then that single z on the bottom. We have all our pieces matching up. This was a great chain rule example. Let's keep it rolling. Great problem here because it's technically it's a word problem, but it's very easy. It asks us to use the product rule to determine the rate, yada yada yada. Product rule is the idea that when we have a function that can be expressed as the product of 2 x terms, we can find its derivative by using this formula, a prime times b plus a times b prime. If we consider product rule and that and how there are 4 different values we are combining in some way. And we think about in this problem, all they've given us are 1, 2, 3, 4 values. Then that should, help you lean towards we need to plug these values into these 4 values here in some way or another. Let's talk about how. The first value they give you is A. The second value they give you is describing how the value of A is changing. It's describing the rate of change of A, or A prime. Because they say it's decreasing at a rate of 13, that's negative 13. Decreasing corresponds to negative rates. The next value they give you is the 1250. That's just a regular value. And then that next value, they are describing how the annual expenses are increasing. They're describing the rate of change for B. And they say it's increasing at 42, which means it's a positive 42. So we take all these values and just plug them in to the product rule. So just working that out real quick. I'll just write it out real quick. Negative 13 times B plus A times B prime. Working this out in Desmos. Should give us negative 13 times 1250 plus 491 times 42. Gives us 4372. That is a positive 4372, which means if we see 2 answers, we are looking for the one that mentions increasing. And that's it. All right. Let's keep it rolling. I think I just got an email. That was for something else. Excuse me. All right, let's keep it rolling. In this one, they give us some price information, some quantity information, some more price and quantity information, and they ask us to find the elasticity. Again, I could see maybe just like a couple elasticity problems on the final, only because, that's very business related. But again, the majority of the course didn't really talk about elasticity all that much. That's why I could only see maybe a few problems. So I wanted to throw this in to reiterate this important equation here. Percent change in quantity. Sometimes it might be represented as percent change in demand. Very interchangeable. More often than not, though, you will treat it as percent change in quantity. And then that's divided by percent change in price. So if we have information about an old quantity and a new quantity, an old price and a new price, we should be able to find the percent change in quantity and then the percent change in price. Oh goodness, I'm mixing up everything. There we go. So percent change in anything is always new minus old divided by old, or we could say Q2 minus Q1 divided by Q1. So what do we know about Q1? Q1 is 424. So minus 424 over 424. Do we know anything about Q2? All they say is that we have 33 fewer widgets than the initial 424. 33 fewer would mean 424 minus 33. 424 minus 33 tells us 391 is actually our Q2. So with this problem, pay close attention to the difference of, like, they're giving us the first price and the second price very directly. They're giving us the first quantity, but then they don't give us the second quantity directly. They just tell us how to find it. Okay, so this is how we'll calculate the percent change in quantity. And again, percent change in price, P2 minus P1 over P1, or new minus old divided by old. New, 1387, minus old divided by old. All right, so this is how we'll find the percent change in each of them, and then we will divide the results. So just... I'll just do this in Desmos real quick. think we will aim to plug in everything at once. So I'm literally going to plug in percent change in quantity. 391 minus 424 divided by 424. Whoops. Divided by 424. And then we're going to take this whole thing, that's percent change in quantity, and divide that by the percent change in price. 1387 minus 12 divided by 12. As a result, we get negative 0.499. Negative what did I say? 4.99? No, 0.499. That was right. So 0.499. Of course, that is approximately negative 0.5. So our elasticity is about negative 0.5 or negative 1/2. All right. So good elasticity practice there. Here's a very standard quotient rule problem. Just wanted to make sure I touched on it before, or just at some point in this review. So quotient rule I could see popping up hopefully once, just because it was a big part of derivatives. Or hopefully not. Maybe you'd hate it if quotient rule popped up. But let's go through it anyway. Quotient rule we want to use whenever we see x terms being divided by x terms. And that's pretty much it. So I'll call it a over b. So the numerator I will identify as a, denominator as b. And we will find out what this formula looks like with all these values plugged in. So let's start off just by setting up what the quotient rule will look like here. A prime times b minus a times b prime. So let's go ahead and divide by b squared. So again, we want b here, a here. So we can go ahead and fill in like 3/5 of this whole formula. So b is the denominator, 3 minus x over 2. A is that entire, let's see if I can squeeze it in, x to the 3 over 2 divided by 2 plus 4 over x plus 2. And then b on the bottom is 3 minus x squared. Or sorry, x over 2. And then the whole thing is being squared. Now all we need is a prime and b prime. So a prime, the derivative of a should be the derivative of x to the 3 over 2. So we would bring out 3 over 2 times x and then subtract 1 from 3 over 2. Just as a brief reminder. When you have a fraction, exponent, 3 over 2, we bring out that fraction, and then to subtract that fraction by 1, my trick is take the top number minus the bottom number. 3 minus 2 gives us 1, and then we leave that over the original 2. So 3/2 x to the 1/2. But then that whole thing was divided by 2. So we leave it over 2. And if we wanted to, it might help us to go ahead and reduce that or simplify that. So if we have 3 over 2 divided by 2, really this 2 would just join in with this 2 on the bottom. So we'd have 3 over 4 times x to the 1/2. All right, that was just the first term. Now 4 over x. Great practice here. So 4 over x. To take the derivative, we first want to rewrite it as 4x to the negative 1. Then when we take its derivative, we can bring that negative 1 out, multiply it by 4, leave the x, and then subtract 1 from the exponent to get negative 2. And then we could rewrite that as negative 4 over x squared. So the derivative of 4 over x is negative 4 over x squared. Negative 4 over x squared. And that's it for a, because that derivative of plus 2 goes to 0. Now b prime is the derivative of 3 minus x over 2. So that is 3 goes to 0, and then minus x over 2. Minus x goes to minus 1, and we can just leave it over 2. All right. Crazy, crazy derivative here. Let's see if we can identify the answer. Something beautiful about this one. look at the denominator. We have 3 minus x over 2 squared. A does not have that. B does not have that. Just like that, we can eliminate A and B. Now, C and D do have that, but which one makes more sense given the mess we have written out here? It's got to be C, right? D does not have enough going on in that numerator. It just doesn't make sense. So by process of elimination, you can make identifying a super complex problem a little bit easier. For anyone wondering why all the terms are positive up top and why there's no negative in the middle, is because they've multiplied that negative in the middle, or that minus in the middle, by this negative here with the 1/2. So negative times negative gave us a positive, and they've actually flip-flopped this, like this second half to the front, and they've put this front half to the back. And hopefully that starts to make this make sense, make that answer choice make sense altogether. All right, let's keep it rolling. Great problem here. I could totally see this on the final. I think for time's sake, I'll probably start skipping over some of the problems I've pulled up, get to some of the graph representations, things like that after this one. So for this problem, what are they asking? Find the marginal profit function and use it at Q equals 14. Let's just stop there. That means we want to find profit, which is of course revenue minus cost. Then we want to find the derivative of profit. Remember, anytime we see marginal, that is another word for derivative when we're dealing with these problems. So then once we have profit, we'll find P prime, because that'll represent marginal profit. Then we will use it at Q equals 14. So we will not just find P prime, or marginal profit, at 14, but we will also find the regular profit at 14. And then I'll talk through what to do from there. So profit is revenue minus cost. Let's see what we know. All we know is that the price is 75 minus 3Q, which means the revenue, price times quantity, is 75 minus 3Q times Q, because they're telling us this is the price. So this whole thing is the price, and this is the quantity. Price times quantity. When we multiply these out or distribute the Q, gives us 75Q minus 3Q squared. Now the cost should be the variable cost, 10 times quantity plus the fixed cost, 80. And now we want to find profit, which is revenue minus cost. So revenue was the 75Q minus 3Q squared, and we are subtracting the cost, 10Q plus 80. Make sure you keep the cost in parentheses. All right. So do we have any like terms? We see a 75Q minus 10Q. That's 65Q. And then no other like terms, so we just have minus 3Q squared. And then we distribute the negative to the 80, so minus 80. This is our profit. Now, let's make some space here. This is our profit, and we want to know what marginal profit is, so we find P prime. Marginal profit is P prime. Derivative of 65Q is 65. Derivative of 3Q squared is 6Q, and minus 80 goes to 0. We have profit, we have marginal profit. Once again, we want to find profit and marginal profit at 14, because they tell us to use it at Q equals 14. P at 14, P prime at 14. I'll just use my phone for this. It'll be a little faster. 65 times 14 minus 3 times 14 squared minus 80. When I did that, I got 242. And then for marginal profit, 65 minus 6 times 14 gives us negative 19. Now let's talk about what this means. This means that the profit is 242 when the quantity is 14. if P prime, or the marginal profit, is negative 19 at 14 for the quantity, if we increase the quantity by 1, in other words, if the quantity were 15, this would make the profit go down by 19. Marginal profit tells us how the profit changes if we increase the quantity by 1. But what are they asking? They're asking us, what would the profit be if we increase the quantity to 16.5 from 14? 14 to 16.5 is an increase of 2.5 to the quantity. And so if negative 19 is how much it changes, is how much the profit changes per one quantity, if we are increasing the quantity from 14 to 16.5, we are increasing it by 2.5. And so the profit will change by 2.5 times negative 19. And that's starting from the initial profit at 14, which was 242. So if we calculate 242 plus 2.5 times negative 19, it gives us 194.5. And that should be the profit estimate at 16 by using the profit information and marginal profit information at 14. 194.5 should be our estimated profit. Hope that process makes sense. Let's move on to the next one. Actually, I might start skipping around here. Do some important ones. So this one is, let's go and do it. It's asking about concave up and concave down given the original function. Again, when you're given when you're given the original graph of f, concave up literally means concave up, and concave down means concave down. So let's scan through these. Concave up over the x values, 1.05 to x equals 3.35. So 1.05 to about 3.35. It looks quite concave up. How can we confirm? The inflection points tell us where the concavity changes from concave up to concave down, or from concave down to concave up, which means we know that a new concavity starts at 1.05 and continues until 3.35, which means it likely is, if it looks concave up to some extent between those two values, then it should stay concave up over that interval based on these boundaries. Let's keep it rolling. Concave up from 0.45 to 1.05. Now, it's impossible to truly see what's going on here. You can maybe make out that it's kind of doing something like this between here. However, this is where the inflection points really come into play. We do know that the boundaries are 0.45 and 1.05. However, if those are telling us where the concavity is changing, then we can't have back-to-back intervals both be concave up. That doesn't make sense. One of these must have been concave down. Specifically, this one should have been concave down. And so this makes all of A false, so we move on to option B. Concave down for 0.45 to 1.05. That's what we said just now that it should have been. Now, concave down for 3.35 to 7.05. Those are boundaries, which is a good sign. 3.35 to 7-ish. That visually is very concave down, so we can just confirm that sort of by looking at it. Number 3, not strictly concave up or down over 4.85 to 9.05. 4.85 to 9.05. That is a true statement. Keep in mind, inflection points tell us where the concavity is changing. And if we see an inflection point, 7.05, on this interval, then that's how we know the concavity changes on this interval at some point, specifically 7.05. So that means that is true. It's not strictly concave up or down over that interval, because it really visually it changes from concave down to concave up between its max and the min. And so somewhere around here, concavity changes. So anyway, that makes B a true statement, or it has 3 true statements. All right, let's do one of these regarding concavity as well. Real quick, we can ignore these. These statements, the first 2 statements, are really just telling us F starts concave up and then changes to concave down. It starts concave up and changes to concave down to some extent. Now, they won't look as explicit as these. They will be a little more subtle in terms of their concavity. So like A, for example, starts concave up because it has that concave up at least half here. So it starts concave up and changes to concave down. B starts concave down, so we can eliminate B. We're looking for the ones that start concave up. C starts concave down, so we can eliminate that, which means D must start concave up. So we're at A and D so far. What's the last statement? F prime at -1 equals 0. Keep in mind, F prime means the derivative. F prime means the slope of F. Slope of F at x equals -1 equals 0, which means the slope of F should be flat at x equals 1. -1, x equals -1. So at -1, A has a very steep positive slope, so that slope is not 0. D has a very flat slope, a 0 slope at -1. So D is our answer. Had it said F prime at -1 does not equal 0, then it would have been A, because that slope at -1 is not 0. All right, let's keep it rolling. No tricks here, but a good little graph one to know how to do. Anytime they're talking minimums, inflection points, maximums, things like that, all the low points are minimums, all the high points are maximums. All the values in between can be considered inflection points in these problems. Again, inflection points are where concavity changes. So, what do they say? D is a relative min. That's false. It's a max. C is a relative min. That's false. It's an inflection point. And then D is an inflection point. That's false. It's a maximum. So none of these are correct. Let's keep it going. In this problem, you are given Q prime. Q represents the sales. Q of S represents the sales, or what is it, the units of product spent on advertising. Oh no, they say sales is Q. Yeah, so sales is Q. So that means Q prime is the rate of change of sales. Anytime you are given a first derivative graph and you want to know where the original function, where the original sales are increasing or decreasing, you don't analyze where Q prime is increasing or decreasing. You analyze where Q prime is below or above the x-axis. Q prime is negative below the x-axis. Q prime is positive above the x-axis, which means where Q prime is positive, sales are increasing. Where Q prime is negative, sales are decreasing. All right, and so really you're just looking for the x-intercept, in my opinion. So that's about 7-ish, which the x-axis is in terms of thousands. So you're looking at one of these 7,000s, and then it's C, because sales are decreasing for values less, because it was decreasing when it was below the x-axis, less than 7,000. And then once it crossed over into the positives, that's where it changed to increasing for greater than 7,000. Again, same idea here. We're given the graph of F prime. So increasing and decreasing is dependent on whether F prime is above or positive, or where F prime is below or negative. So when it's above, F is increasing. When it's below, F is decreasing. And I'll just leave it at that for this, and you can analyze increasing or decreasing for those intervals. for this one, I'll just briefly talk through the process. You'll find g prime of x. You'll then factor out a 6. You can pull out a greatest common factor. Set it equal to 0. Then you'll be able to factor this into 2 smaller factors. You'll find these x values, say x equals 2 and x equals 6. I don't know what they are, but I'm just making ones up. Once you find these, you'll plug these into g, the original function. Whichever g value is higher will be the max. Whichever g value is lower will be the min. And then you take one more derivative, g double prime, set that equal to 0, and solve for x. And then once you solve for x, you'll plug that value into the original function, g, as well. That will give you the g value of the inflection point. Let's see if we can do some fun stuff. Here's another good graph one regarding f prime. You will find where f has maxes or mins when you're given f prime when you look at the x-intercepts. X-intercepts of f prime tell you whether it's a max or a min. Specifically, where it crosses from below to above, or when f prime changes from negative to positive, that's where f is changing from decreasing to increasing. So decrease to increase gives you a minimum. So below to above is a minimum at this point, at that x-intercept value. And then above to below represents a maximum, because that represents where f is changing from increasing to decreasing. And so the rest of these, minimum at like 5 point something, maximum here, and I'll leave it at that. Sorry to be breezing through. I'd rather touch on a lot of problems rather than fewer in depth. All of these should be posted to YouTube, so feel free to check out the longer videos for them. Great problem here. I know these are intimidating. Let's break them down. From here, we get the x values, 5, 1, and -4. These are the x values for which f prime is equal to 0, which means these are critical points. These are possible locations for where f has maxes or min. So that's how we eliminate 2 of the colors here. Let's just look at x equals 1. When we look at x equals 1, we're looking for the 2 colors that have either a max or a min at x equals 1. So looks like green has a max and pink has a min. Again, we are looking at f now, as opposed to this one where we were looking at f prime. When you have f prime, the x-intercepts are where f has maxes or mins. When you're looking at f, maxes and mins literally mean high points or low points. All right, so x equals 1 has maxes and mins for green and pink, so we can eliminate blue and orange. Now, we plug in 0 to the function, to f prime. Plugging in 0 here, we get 0 minus 5 is a negative, 0 minus 1 is a negative, 0 plus 4 is a positive. So we analyze the sign of f prime when x equals 0. 2 negatives and a positive multiplied together give us a positive. An even number of negatives gives us a positive. An odd number of negatives multiplied together give us a negative. This tells us f prime at 0 is positive, which means f has a positive slope, specifically at x equals 0. Where is x equals 0? X equals 0 is right in the middle. It's right along the y-axis. Can't draw a straight line, but you get the idea. So right in the middle, between pink or green, which one has the positive slope? Pink has a very negative slope in the middle, and green has a very positive slope in the middle. Therefore, green is our answer here. Wonder if I can do one more real quick. Here's a good little one. I'll just end on this one. We've covered a lot of good problems today. I hope this serves as extra good information to a lot of you. I hope you find this useful. I know not many people were tapped into this morning. I understand you might have had other things going on, sleeping, whatever, but you can always, scan through this video. Hopefully you've gained something from it. All right, so this is the graph of f double prime, the second derivative. What's the relationship between f double prime and f? When f double prime is positive or above the x-axis, that tells us that the original function is concave up. And just the opposite, where f double prime is negative or below the x-axis, that means that f is concave down. So in this case, if this f double prime function starts below the x-axis and changes to above the x-axis, we are looking for the function f that changes from concave down to concave up. Concave down to concave up. So that forces it to be D. And that's it. All right. Hope this makes sense. Here's some other good problems I've picked out to practice, but we did not get to. Again, I have videos on all of these same problems. Thank you for tapping in. Really practice this problem. There's like a 200% chance of this being on the final. Go ahead and practice that. Here's another good revenue one. Probably solid. This is from like one of the last sections. Probably recommend that. This, maybe not so much, but you never know. Yeah, same thing with this. It might pop up. Probably not, though. I could see this one popping up. Could probably see this one popping up. These are just good extra ones that I thought were good. In my opinion, in my experience, I think they're strong final exam problems. And I think this was the last one. So we made it pretty far through these. Aiden, I appreciate you saying you appreciate it. I'm happy to help. Thank you for tapping in to those who did. And, if you're just checking this out later on YouTube, I appreciate that as well. Sorry the webcam didn't work today. Don't know what's up with that. Here's my little face there. That's fine. So we're just going to call it here. Thank you for checking this out. If you'd like to make a donation, remember my Venmo is Carter D with 3 E's in the last 4 digits. My phone number is 6910 if it asks for it. So again, I have a little review sheet in this description here, so feel free to reference that if you'd like. It has some solid stuff. All right. Thank y'all so much.